Good evening, everyone. My name is Chomoji. My channel is officially set up, and this is going to be the first video. Woo! So the name of the channel is Physics Jota by Chomoji. Stay tuned and follow us as we unveil the beautiful package in it. So tonight I'm going to be answering a fan from Twitter. In case you're not following me on Twitter and you're here, please follow me on Twitter using the handle hovering around your screen. So the introductory part of this will be posted on Twitter. Then all the remaining parts, because the video is going to be so long, will be posted on this channel. So if you're following me here, the first video here will be the introductory part. Then the other parts will be here. So like this, my explanations and everything will be here. So if you're following me, subscribe to this channel. If you're seeing me for the first time, subscribe to this channel and also follow the link or the username on the screen to follow me on Twitter. You can drop your questions there or you can drop your questions here. Whichever way I am going to see it. God bless you. So today I'm going to be answering a username from Twitter at ICOS Andrew. So he says, so in his question he said, show that a particle in a central force field is square over the theta equals that second derivative minus f is a function of 1 over u over m k square u square. But before we continue, I would like to tell you that this question here is not correct. And the reason for that is that there cannot be a second derivative of anything with respect to no function. It has to be with respect to function, and I'm going to prove it to you by converting this, which is in polar coordinate, into Cartesian coordinate, then back to polar coordinate, so that you see this equation is not complete and this equation is wrong. So the right form of this equation is d square u over the theta, which is the second derivative, which shows for acceleration, equals minus f is a function of 1 over u over m here's u. That is it. Now this is the equation we are working with. We want to show that a particle in a central force field is equal to this. Before we go, we break this down. This is Cartesian coordinates. You have x, you have y. This is it, a particle going in p. Let's call the particle p, and it's a function of fr, which is also just going to be a function of fx. Now breaking this thing down in Cartesian form, you have fx is equal to the limits as x tends to 0, f brackets the change. What is this change? The slope. That is the change. The slope is the change from this point of 0 to this point, and from this point to this point, which is what the change. What happened here? X, which is the point here, let's take this as the point of study, plus the x, which is the change, minus initial dx, that's the change, over the x as x tends to 0. And when you talk about x tending to 0 in the graph, x can be any point. If we talk about the absolute value, either negative x or positive x. If x is coming from here, it is from this point, it is negative x. If it's coming from this point, the positive point. But absolute value of x, let's assume that this is the absolute value where positive and negative have been neutralized. So this is it. Now taking f equal to x equal to f equal to u, and u equal to 1 over u, we want to show using the polar. But first of all, converting this into polar form, there's one thing we need to know. And that first thing we need to know is that the particle, let's just say this is the particle. This particle is moving in a central force at any point. So in a particular point, they say we should show, let's say the point is P, and at this point is f of r equal to f of u equal to f of 1 over u. So at this point, we are taking a radial direction, which is r, and we are taking an angular displacement, which is theta, from this side. So we are taking the tangential of it. So taking it, finding for polar r and theta, of course this is in 2 dimensions, 2D. So while we are taking for these two in 2D, we are trying to find in polar form, convert to polar form. So converting this to polar form, you have from Cartesian, you have r squared equal to x raised to power 2 plus y raised to power 2. But you know, from SOHCAHTOA, you have SOHCAHTOA. From SOHCAHTOA, we have, using from this place, we have the conversions to be r squared equals substitution, because from SOHCAHTOA, sine this, we have r cos theta equals x, r sine theta equals y. Then tan inverse of y over x equals theta. That's the tangent. Substituting it into this, we have r equals r square bracket cos square theta plus sine square theta. This cancel this. This is a variable, cos square theta plus sine square theta. This is a constant. Let's call this equation 1. This is a constant. Let's stop here and see you in part 2.